and welcome back to Riya Kankonkar's channel. Today we'll be having fun with lesson number 1, Similarity, practice set 1.2. Let's get started. We will be solving question number 1, 2 and 3 from practice set 1.2. Question number 1 has 3 sub-questions. Question number 1 asks us to identify in which figures ray PM is the bisector of angle QPR. This is the diagram for the first sub-question of question number 1. Here it shows us triangle QPR with the bisector PM. So here is the solution for the first sub-question. It tells us that QM upon MR is equal to 3.5 upon 1.5 as shown in the figure. Therefore, QM upon MR is equal to 35 into 10 upon 15 into 10. We have multiplied 10 to both the figures to remove the points. Next step is we cancel both 10s from the numerator and the denominator. So now we are left with only 35 upon 15. Therefore, QM upon MR is equal to 7 upon 3. That is the first step. And the second step is QP upon PR is equal to 7 upon 3 as shown in the figure. Therefore, from 1 and 2, as both the right hand sides of step 1 and step 2 are equal, therefore, the left hand sides of step 1 and step 2 becomes equal. Therefore, we can say that ray PM is the bisector of triangle QPR because of the converse of angle bisector theorem. Now let's see the solution for sub-question 2. It tells us that RM upon MQ is 6 upon 8. After dividing, we get RM upon MQ equal to 3 upon 4. That is the first step. And the second step is RP upon PQ is equal to 7 upon 10. That is given. Therefore, step 1 and step 2 tell us that they are not equal. That is why ray PM is not the bisector of angle QPR. Now let's move on to sub-question 3. It tells us that RM upon MQ is equal to 4 upon 3.6. Therefore, RM upon MQ is equal to 4 into 10 upon 36. Here, 10 is multiplied by 4 and divided by 36 to remove the point from the number 36. Now, the next step is RM upon MQ is equal to 40 upon 36. Therefore, RM upon MQ is equal to 10 upon 9 is the first step. The next step is RP upon PQ is equal to 10 upon 9 as shown in the figure is the second step. Now from 1 and 2 we come to a conclusion that RM upon MQ is equal to RP upon PQ. Because the right hand sides of both the steps are equal, the left hand sides become equal too. Therefore, ray PM is the bisector of angle QPR due to converse of angle bisector theorem. So this was all for question number 1. Now let's see what is waiting for us in question number 2. Question number 2 tells us in triangle PQR, PM is 15, PQ is 25, PR is 20, NR is 8. So state whether NM is parallel to side RQ and give reason for the same. This is the diagram for question number 2. Here we see PM is 15, PQ is 25, NR is 8 and PR is 20. So now let's move on to the solution. So it starts with given. It tells us in triangle PQM PM is 15, PQ is 25, PR is 20 and NR is 8. We have to prove that line NM is parallel to side RQ. Therefore, the proof tells us that Pn plus Nr is equal to Pr because they are collinear. Now, Pn plus 8 is equal to 20 as we substitute their values. Pn is equal to 20 minus 8. When we shift 8 from the left side to the right side, the sign changes from plus to minus. Therefore, Pn is equal to 12. Now, as we have found out the value of Pn, we will substitute it in the next step. That is to find the ratio of Pn upon Nr. So, Pn upon Nr is equal to 12 upon 8. Therefore, Pn upon Nr is equal to 3 upon 2. Now, let's move on to the next step. That is, Pm plus Mq is equal to Pq as P and Q are collinear. Therefore, 15 plus Mq is equal to 25. Therefore, Mq is equal to 25 minus 15 as we shifted 15 from the left side to the right side. The sign changes from plus to minus. Therefore, we have found out the value of Mq, that is 10. Now we will substitute this value to find the ratio. That is, Pm upon Mq is equal to 15 upon 10. Therefore, Pm upon Mq is equal to 3 upon 2. So, from 1 and 2, we come to a conclusion that Pn upon Nr is equal to Pm upon Mq because their right hand sides were equal, that is 3 upon 2. Therefore, Pn upon Nr is equal to Pm upon Mq. That is why line NM is parallel to side RQ because of the converse of basic proportionality theorem. This was all for question number 2. Now let's move on to question number 3. What does question number 3 tell us? In triangle MNP, NQ is a bisector of angle N. If MN is 5, PN is 7, MQ is 2.5, then find QP. Before we move to the solution, let's see the diagram. It tells us Pn is 7, Mn is 5 and MQ is 2.5 and we have to find QP. So now let's move on to the answer. It tells us given is in triangle MNP, NQ is the bisector of triangle N. And we have to find the value for QP. So now let's see what is the solution. It is Pm upon Mn is equal to Qp upon Mq according to the property of angle bisector theorem. Therefore, 7 upon 5 is equal to Qp upon 2.5. That is, 7 into 2.5 upon 5 is equal to Qp because 2.5 gets shifted from the denominator on the right hand side to the numerator on the left hand side. Therefore, in the next step, it tells us 7 into 25 upon 5 into 10 is equal to Qp. How? Because we wanted to remove the point from 2.5, we divided it by 10. And now we have got 7 into 25 upon 5 into 10 is equal to Qp. After calculating everything, we get the value of Qp as 3.5. So this was all for today. We will meet in the next video and have fun again. Until then, bye.